Hey, welcome to Luke's Dev Lab. My name's Luke. I've been building software and working as an engineer for 8 years, and I'm here to help you cut through the hype and find out what AI can do for you. And in this video, I want to look at the Qwopus 3.6 27B coder model, the MTP version. So the specific model we're going to be using in this video is we're going to be going with the 4-bit, and then we're going to go with the Q4KM. I'll have this page linked down below as well if you want to check this out. And credit to Jackrong for making these Qwen fine-tunes on Opus reasoning. We're going to run the model through 3 coding challenges today. So we've got the 2D driving game, which you'd be familiar with if you've seen some of my videos, the sand physics one, which was a new one in the last video, and then a new one, dungeon crawler, which I'm yet to test, so we'll see how that goes. And then just a quick look at the system this is running on. So this is a separate system in my house. We're running with 16 gigs of VRAM and then 32 gigs of DDR4 for offloading, which we will need to do on this 27B model. Now I did want to include a 4th test here with some Python. I know some of you have been asking for that, more diverse testing, not just HTML, and I'm working on it. My tests so far have had this not working within my test suite, but once I can get this working properly, then I'll be able to bring some good Python testing in. No, it's in progress and I'm working on it. Hey, Future Luke here. So I actually managed to get the HumanEval benchmark working, so we're going to cover it. Just a quick run through, it took almost 3.5 hours to get this benchmark to run. Essentially, if you're not aware, HumanEval is a benchmark by OpenAI, and it consists of 164 handcrafted Python problems. So this page from IBM describes it perfectly. It's a benchmark for assessing code generation capabilities of large language models developed by OpenAI, and essentially it's designed for Python generated code. It goes beyond syntax, validating the code created as both accurate and functions. So it actually tests that the functions run. So I'll link down below to the GitHub page for this evaluation. And then for now, let's dive into the results. So for our Qwopus Coder 27B, we've got a 77 pass rate, 126 out of 164 have passed. So that's not too bad a score there, I would say. We can go through some of these. I'll probably start putting the reports on my website as well so that you can go through them yourself. Because it's the first time I've run this, we don't have anything to compare it to yet. So, but yeah, going forwards, I'm definitely going to be running this benchmark on models. Alright, so let's jump into our first test, the 2D driving game. So I've got the prompt here. If you want to have a read of it, feel free to pause the video. Otherwise, it's linked down below in the GitHub as well. So we're going to copy that over, and again, same as last video, I'm using Qwen in VS Code now because I found it better than OpenCode. So we'll let this run, and then we'll come back and check if there's something to see along the way. Otherwise, we'll check in when it's done. Right, so we've got our driving game back. We've got some instructions on how to run it. So let's follow the instructions and see how it is. Alright, let's open this. It doesn't look like it's working. I was going to open it in my web browser, but yeah, maybe it's not worth it yet. I'm not seeing a car and we can't move, so yeah, let's get this sorted. Alright, so I've been working at this for quite a while now, and it doesn't really seem like we're getting anywhere. So I told it the car won't move, and then, okay, it's just thrown me into the game to test it. It's regressed, it's worse. Now we can see nothing. So yeah, as I was saying, I said, the car won't move. It said it did stuff. I said it was the same, and there's no errors in the console either. So it did more stuff. It came back. I said, nope, no change still. And it did more stuff, and it did stuff for a while. It's been going for a while. And then it said it was done, and yes, what it just opened there was what it's done. So it has regressed. Sorry, that's what it is. So yeah, I don't think it's worth too much time on this test anymore. Let's move on to the next one. So we're just going to do a little comparison at the end result of the driving game here. So this was what the coder model did for us just now. But if we look at what the Qwopus 27B non-coder did in a previous video, it's not perfect, but this is a hell of a lot better than what we currently have. So yeah, from this test, just this comparison here, you can see the non-coder model did a much better job. And then if we just run the 27B Qwen, so not Qwopus, and I would say even this one is not too bad. In fact, I would say this one's better than both of them. So yeah, a bit of a fail from the Qwopus coder in my opinion. So we've got our sand physics prompt here from the previous video, but there's a new element in it now, so we've added acid as well, which should degrade some of the other elements. So I'm hoping this model is going to handle this new version of this prompt, so we'll have a look in a bit. And as always, prompts are in the GitHub link in the description for this video and all the prompts I've run across my videos. Okay, so the model has come back with our sand simulation, so let's have a look at what it's given us. Right, so we've got sand, it's working nicely. Let's try the water. Nope, that's a miss from the water. Can we make a wall? No. Acid? No. So what if we go back to sand? No. Okay, so it seems like the switcher is causing a bug, so let's get that fixed. Okay, it's come back again, said it's made some fixes, so it's fixed the material switching bug, it explains why it was happening, so let's see if it got it right. So sand, yep. Right, water, yes. Okay, cool. So let's go with a wall, yep, nice, that's working. And then let's try, before we move to acid, let's fill this up. Yep, that's working nicely. And then we'll go with acid. So yep, that's dissolving the other elements. Very nice. And then let's just bury that with sand. Okay, so yeah. Brush size, let's just do, yep, larger. And then clear. So yeah, very nice. That's a good pass on that test. I quite like this one. It's quite a fun little game, if you can call it a game. Alright, so we've got our new prompt here. This is our dungeon crawler. Again, pause the video if you want to have a read of it now. Otherwise, you can check this out in the GitHub link down below. And we are going to pass this over and see how it does. Okay, and we've got our dungeon crawler back. So let's just let it finish giving the summary here. So the procedural dungeon generator with dynamic fog of war is complete and ready to use. Here's what's implemented: map generation, binary space partitioning, raycasting line of sight, Bresenham's algorithm. We've got our controls. So it seems to have followed the prompt quite well based on this summary. So let's jump in. So we'll make that bigger. Just give it a reload just to make sure we've got the absolute latest. Okay, so yeah, refreshing it is generating random. Let's see. Yeah, not quite. We want the map to reveal as we move around. So yeah, let's go back and improve upon this. Okay, apparently the bugs have been worked on. So let's have a look. Oh. Okay, any errors? Yep, okay, let me pass these errors over to the model. Alright, we've got our dungeon crawler back again, and I think we've got something working now. So if we jump over to it, if we press regenerate map, we do move around, and then we can move, and as you can see, the fog of war is working quite nicely there. So we can pass through. It's keeping where we've previously been, so that's quite nice. So yeah, we can go through this way. So yeah, that is looking quite good. And if we do God mode, yeah, we can reveal. Okay, you couldn't get through here, so it looks like I was about to hit a dead end. And then, okay, so you can regenerate. So it looks like sometimes you'll just spawn in a room you can't escape. So yeah, we can just, okay, once God mode's been put on, that's it. That kind of makes sense. So yeah, it took us a while to get there though. Let's review the code. So, gave the initial prompt and then it delivered, and the problem initially was the map was not persisting the fog of war. So as you revealed the map, it wasn't staying revealed. And then also there were no walls, so it was just a big empty room. So prompted it again, came back. We had an issue, a bug that prevented the game from working. It fixed that, and then there were still no walls, but it was persisting with the fog of war. So then after that final prompt, that's the state we're in now. So it took a few prompts to get there, not too bad, but the end result is quite nice. And remember, this is all in one file, no frameworks, no libraries, so it's had to implement all these algorithms itself for the raycasting, for the random generation of the rooms. So yeah, there's a lot of logic going into this one, regardless of the language. This just proves the model's skills with algorithms and logic. So a good test to use going forwards, I think. Alright, so that brings us to the end of the video. What did you think about the Coder variant of the Qwopus 27B? Personally, I think it's not as good as the non-Coder version. And then in my previous test, looking at Qwen versus Qwopus 27B, I actually preferred the base Qwen model. So just my opinion on it from my testing. But what I am going to look at in the next video is Qwable. So we've done Qwopus, which is Qwen trained on Opus. So as you can guess, this is going to be Qwen trained on Fable, the model that we can't even use at the moment. So get subscribed if you want to see that video. Thumbs up if you enjoyed it. It does help the channel, and I'll see you in the next one. Bye.